Alrighty. So from last time, we talked about this particular simple problem over here. The microphone sounds a little bit weird. Can you still hear me without a microphone, right? Okay. What about just without using a microphone? Okay. Okay. So the example we talked about last time, let me remind you very quickly about it. So eventually, by the end of the day, we're going to show you 5 different versions of the Java. Why? Because Java simply didn't support the side-by-counter so easily to be done. By the end of the day, we're going to have some Java code with lots of scaffolding that you have to implement if we taught this course in Java. Okay, so let's see. But I'm not just trying to. I'm not focusing too much about the syntax. I'm focusing more about the ideas. How we do design by contracts. Okay, to remind you about it. So this is the problem that we are trying to solve very quickly. So now we're focusing on these 2 requirements. We have requirement number 1. So the most important thing is the balance must be always positive. Okay, larger than 0. Okay, and then withdraw over here is simply say you can withdraw an integer. It doesn't say too much about it. Okay, that's the nature for requirements being vague and informal. Okay, let's now go back to our first version over here. Okay, I'll only just show you the code very quickly. Okay, we got this first version here. We criticize that at least from 3 different perspectives. Balance for the initial account can be negative, and also the amount over here can be either negative or just too large for you to withdraw. Okay, that's the issue we talk about. Let's now see how we can fix this issue over here a little bit by moving on to the second version. Let's see a little bit slideshow, and then I'll show you the code on the iPad. Okay, so let me just go to the first version over there. Okay, how can we improve it? So now we want to talk about a notion about preconditions. Of course, if you have done lab 0, you have seen the required clause for IFO. But I would say don't be too bothered by just the syntax. It's more about the concept that we're talking about, preconditions. What is really precondition? It's basically the obligation for the client to satisfy before they can call the service from the supplier. Okay? And that's also the benefits for the supplier, so they can assume for me to provide a service, the precondition must be the case. Okay? And another way to think of it, precondition is really like a condition for service. However, you don't really have that notion of precondition in Java. Well, you might argue that, well, you told me in 2030, if you took 2030 with me, we can do precondition using exceptions. I didn't tell you the whole truth, actually. What we did I didn't lie, but I didn't tell you the whole truth, okay? What we did in 2030, we try to do preconditions using exceptions, basically, right? If you say, okay, if the amount we're trying to withdraw is negative, throw amount negative exception. That's what we did, right? However, that condition there is not exactly a condition for you to serve. It's more like a condition to say when should the program crash, right? It's different. It's different. Okay. So let's just go over that. Okay, and then I will show you more example. So now let's just get used to the notion about precondition. Forget about IFO and the Java for the moment. Okay. Now precondition is really a surface condition. What should be the surface condition for divide? Yes. Yeah, it cannot be do divide by 0. So now which parameter should you constrain? Y, right? So in this case, that means y cannot be negative. Cannot be 0. So y should not be 0. However, I want to draw your attention right away to make my points. Okay. Now, if I want to encode that particular precondition, now let's bring the programming languages into play. Okay. Add a page below, and then use current template. So now let's say we talk about a precondition over here, and then as I said before, it's more like a surface condition. Okay, surface condition. And then the method or feature we talk about, let's divide them into two places. Okay, let me say this. Okay, I'm going to talk about Java on the left-hand side. I'm going to talk about IFO on the right-hand side. Let's talk about how you would code this precondition here in Java. Okay, what I need to do is, it's a bit too thick. If I say divide over here, first, let's be purely Java. Let's say I want to return just an integer, make it very simple. Divide, and then I got integer x, integer y. Okay, so what I will have to say is as follows. if y is equal to 0, and then I will need to say throw some exception over here. Agree? Okay, that's only a sketch. Of course, as part of the interface, you got to say throws, whatever that exception is. That's how you do it in Java. However, this condition here, y equals 0, is not really a condition for you to serve. It's really a condition to say, if this condition is satisfied, there's an error. So this is not exactly precondition. Okay, let's contrast. How would you do it in iPhone? You're going to say divide, of course, and then, of course, we can talk about syntax a little bit more next week, but I will simply say x and y are both integer, and then it's going to return an integer. I'll just say int over here. So now what we will do, of course, we can use a require, okay? That's a keyword for precondition. Now, what we will put is y is not equal to 0. So now I want to draw your attention to these two conditions here. Y equals 0 versus y is not equal to 0. They are different. At the same time, they are connected. How are they connected? One is the logical negation of the other. Okay? That's something you want to notice. Okay? So what we want to say, number one, so in this case, in Java, this is more like an error condition. To say under what circumstances should you signal an error. In this case over here, this is more like a surface condition. Okay? That is really the simplest example for you to really see what's really semantic meaning for the exception in Java and the required clause in iPhone. One is really about the error condition. The other one is really about surface condition. Okay, are we okay so far? Okay, you will see such thing all over. Okay, which one corresponds more to precondition? Well, of course, surface condition. That's only one thing. Well, you might argue that, well, you know, it's easy. Every time if I want to program a particular precondition, I'll just logically negate it and put it in Java. Yeah, that's true. But there are actually more disadvantages to this than you might think, which we'll go over. Okay, that's number one. This one is more logical. Okay, I'm just saying the exception that you learned back in 2030 is not exactly precondition. It's only an approximation of precondition. Okay. All right. So now let's go back here. Oh, so now let's do another precondition. I think this one we did it already, right? Let's try again. Let's say I have a method here, do the binary search. I got some integer x to search for within an array xs. What should be the precondition in this case? xs is sorted. Now, let's go a little bit further. How would you formally specify xs is sorted without using a loop? When I say formally specify, I'm not saying about programming. Use what you learned from 1019 or 1090. Okay, let's do this exercise all together. That's something you may have to write for lab 2. And you definitely have to write it in lab test 1 or 2. Okay, I'm just telling you. Okay, good. So now let's see together, okay? So now what I want to do is, let's say we have, okay, sorry. Thank you. We got binary search, okay? And then we have x, okay? And also we got xs. Okay, xs is the array. I just want to write it down, okay? Now, I want you to tell me formally, I'll say math over here. I want to say the precondition should be, let's say xs is sorted in non-descending order. Okay. Anybody want to try before I give you hints? Yes.
For all ij, if I is greater than j, then I is greater than or equal to x of j.
So what's I and j then?
This is the index.
Oh, meaning I and j are the indices for the array. Okay. Oh, I see. For all the I and j, okay, I see what you mean. That's pretty good. Okay, I like that. You know, even though we can simplify that a little bit, but we will write down your solution anyway. Okay. You're basically saying the following: for every I and j, such that, okay. Let me put it this way. Let's say arrays start with the indices 0. Let's say, okay, just 0 less than or equal to I and j, less than or equal to xs dot length minus 1, right? Valid indices, okay? It is the case, okay? Now, help me make it a little bit more formal. What should I do over there? So here I'm constraining to say I and j must be valid indices as you suggested, but now, how do we say if somehow I and j represent not the same indices, but let's say I occur before j, what should be the relationship between the corresponding elements, right? How can we specify that logically? Yes?
If I is less than j, if xs if I is less than equal to.
Yep. When you say if is not a logical term, is it? What logical operator would you use? Implies, yeah. The most scary operator in the logic. Okay, you want to get used to having implies, throughout this course. Okay, I less than j implies xs at I less than or equal to xs j. Make sense? Okay, that's one way to do it. I agree. That one absolutely works. Okay, is it possible to use only one dummy variable? Why don't we try? I'll write it down for you. That's more what I'm thinking. But I do like your solution. That's pretty good. Okay, that's solution number 1, which works. Okay, let's go for the second version of the solution. Let's try it here. What about this? For every I, only one dummy variable such that 0 less than or equal to I and less than or equal to xs dot length minus 1. I'm not suggesting this is correct. You can challenge me. Is this correct? Aha, very good. Okay, anybody who think that's not correct, raise your hand. Explain why. Should be length minus 2, agree? Because we got I plus 1 over there, right? Okay, be careful, all right? Why? Okay, let's see one example. All I'm talking about over here, you got to use them throughout the course. Okay, we are not wasting time. If this is the array that we are talking about, okay, let's say, the array starts from 0, 1, 2, 3, 4, and 5. The length of the array in this case is simply 6. If we go according to this particular logic over here, what's going to be the value for I? It's going to be starting from 0, 1, 2, 3, 4, and 5, right? Now, when it is 5 plus 1 will give you 6. Index out of bound exception, right? So how do we fix it? Well, minus 2. That will also work. Okay, that's the second version. And now the next question. Oops, sorry. You really want to make it believe you're drawing a square, not a circle. Good. Okay, we got two versions. Both versions work. Okay, you can choose either one. Now, next question. How would you code this up in Java? Well, I tell you what, it's doable. You need a loop. For the first one, you need a nested loop. Okay? Let's see how it will look like in iPhone. Hopefully that will make you a little bit more convinced. You will say, thank God, I didn't have to write this in Java. Okay? Let's see. Let's see the corresponding case in iPhone over here. Okay? For the green one, all you got to do is use the so-called across syntax. Okay? Let me just put it side by side so you will see exactly what I'm doing. Okay? Put it here. I will do the red version. Okay? For the green version, you can try to do it a little bit later. Okay? The green version definitely needs some nested across. Let's do the red version. Okay? This is what you got to do. You're going to say across. Oops. Which is a keyword in iPhone. Across an integer interval, which will start from 0, vertical bars, dot, dot, okay? And then to XS, and the array is a class in iPhone. You don't say length, you say count. Okay, that may be something you have picked up already, but if not, you can just learn it. And count minus 2, which means across, S, I. Okay, this is basically saying, I will just write it down and I'll explain to you. You might find something peculiar, okay? All and end. And then I would say XS I dot item, okay, less than or equal to XS I dot item plus 1. I would say it's about 90% similar, if not more, right? It's only a few programming details you have to pay attention to, which I will point out to you right away. So you wouldn't find any difficulty. That looks very much like math. But in IFO, a piece of code like this, which corresponds to math, is executable at the runtime. Which means if you specify such precondition at the runtime, it can be monitored for your feature. Which means before I call binary search, it's going to call this particular piece of code and make sure mathematically speaking, it's going to oblige the clients. Okay? Now, only one thing I want to mention to you, which is also very common confusion. In math, the I over here is a dummy variable. Okay, that's what we learned. However, the I over here, you can think about conceptually as a dummy variable, but more precisely, it's a cursor variable. Cursor, like what you learned back in 2031, maybe, when you have a linked list, you can maintain a cursor to every position in the list, okay? So now you can think about this particular integer interval over here. Let's say, let's say this. This integer interval, let's use this example over here. So it's going to be from 0, 1, 2, 3, only 3, okay? Only up to here. 0, 1, 2, 3, 4. So this is an integer list that's maintained by IFO. And then I is simply a cursor variable. And I is simply just going to point to one number at a time. Okay, just a cursor. However, you just cannot say I directly over here because XS is an array. It is expecting an integer value, not a cursor variable. That is why you want to say whatever value that's currently being pointed to by I, I'm going to retrieve it, which is going to be I.item. That's the only technical detail you have to pay attention to. Okay? Let me just say that one more time. Every time when you're trying to use the across, you have to typically declare some cursor variable that pretty much corresponds to some dummy variable in the corresponding math. However, you want to make sure you say the item over here, because after all, it's a programming language. So you have to say cursor and then whatever it is pointing to. It might be pointing to here, in which case I.item will be 1, right, etc. Questions?
What does that say for side across 0, 1, dot, dot?
Okay, good. So what you're pointing out is over here. So that's also a very convenient syntax you can pick up over here. So let me highlight it. So basically 0 and xs.count minus 2. You are specifying the lower bound and upper bound between, for interval, right? And this syntax over here looks a little bit odd, but that one there, vertical bar, dot, dot, vertical bar, is going to create some integer list on the fly. You don't have to declare the list. You just create for you. And then the cursor variable I is going to point to one number at a time, starting from 0, 1, 2, all the way to xs.count minus 2. Okay? Questions?
Yeah, you said I is pointer.
I is a cursor pointer, yes.
Right. If I'm right, I believe you created different type of class which specifically said that all variables are the actual values.
I talk about Java or iPhone.
You can have two different types of classes.
You can have two different types of classes. I'm not sure why it would be relevant here, though. Are you trying to suggest a different way of writing it, or?
No. When I read the notes, I believe you can make two different types of classes. One that automatically makes a pointer, and one that actually.
You know what? To avoid confusion, how about point to me that particular passage, and then I'll clarify that next time. Yeah. Okay. Yes. Question. Correct. That's correct. So that's exactly what you have to write for iPhone. Okay. Now, of course, that corresponds pretty much to math. All right. And now, number one, you have to, as I said last time, you have to review your math lesson for 1090, especially how you do logical argument. Implication is one of them. Oh, by the way, in iPhone, if you have to write implies over here, they have a keyword called implies. It's a keyword in iPhone. Okay, hopefully you saw it too. Okay, any question about this? For this? Okay, good. It's a very common pattern for writing precondition and code. Yeah, go ahead. Yes. Sorry, which one? I didn't see you. All right.
So, from what I understand, it executes this code in almost the same way that the Java code would be executed. It creates a list and it puts the...
Yeah, so imagine how convenient, well, again, syntax may not be so important, but I'm just trying to say it's more convenient for you to do such precondition stuff, which is related to design in iPhone. Let's say if you want to do it in Java, it's possible. You just have to write explicitly a loop by yourself, and then to check some condition inside the loop body and then return something. But now it's actually built in for you, right? Okay, good. Now we'll see more example. Hopefully we can see another one. If not today, then maybe next week. All right, that's good. And what I will do is, let's go for another one example. Okay, XS is sorted. Now, this is something I wanted to delay from last time. Okay, this one is interesting. You know what a topological sort is, right? Okay, don't look at the slides. Okay, yeah, if you have access to the slide, don't cheat. Okay. Oh, have you learned about topological sort in 2011? Oh, that's too bad. It wouldn't be fair to ask you this, right? Okay, basically, topological sort is a graph algorithm, which means if you got a particular kind of graph, you can figure out the dependency among the vertices. You didn't learn it?
We learned that in 3101.
I think, well, okay, good. Okay, so you know about it, right? So the topological sort. Let's say I want you to program a method called topological sort, and the input is simply just a graph. Okay. Now, based on what you learned in 3101, what should be the precondition for this? Okay, you got answer? Okay. Anybody else? Yeah, I'll come to you. Anybody else? You know? Okay, let me give him a chance. He hasn't spoken. Yeah. It's not okay. It's acyclic. It's not a. Doesn't contain a sign code. Huh? Okay, it's a directed acyclic graph. Okay. Okay. If you don't know what I'm talking about, look at your 3101 notes. Okay. Okay, it's a DAG, directed acyclic graph. Okay, it's just one example to show you. Okay, that's about preconditions, and then so now the question is, how do we improve the first version after we talk about all this stuff? We want to add preconditions, okay, to your Java code. The best way you can do it is by encoding the logical negations of preconditions as exceptions in Java, okay? That's the best you can do. So you're going to say, you will throw this exception if the negation of the precondition is true. It's kind of indirect, right? Okay. And also you can do that. You want to throw the exception for binary search if it is not sorted, rather than saying, I will serve you for binary search if it is sorted, right? So compare the two versions over here. Okay, okay, and then also topological sort as well. Okay, so now precondition, okay, as I said before, so precondition is really about what valid inputs are, as opposed to, in the case of Java exceptions, it's really about what invalid inputs are. Okay, so they're different stuff. Okay. Now, what's more? Okay, I'm going to show you in version 2 what can be the disadvantages for having to code so many exceptions for preconditions. Okay, not only that you as a supplier will have to code them up directly, but also your clients, they will get stuck. Oh, no, not get stuck. They will suffer. Yeah, that's the word. They will suffer. I'll show you why. Okay, so now number 2. Okay, let's see if that's the code. Okay, let's see the code very quickly. Okay, now the code is over here. Yeah, I know, good. I know, I do know. Okay, now this is the code. Let me show you at one go. Basically, you see that over here, I highlighted all the error conditions over here. Okay, so this is an error condition. Okay, for example, if the balance is less than 0, then I'm going to throw balance negative exception. It's already an improvement from version 1. Version 1 doesn't check anything, but now we do check something. Okay, and now we also got if the amount is less than 0 is negative, you got to throw a particular exception. If it is something else, you got to throw another exception. Now, imagine this. Okay, what if I got 10 different preconditions for you to code? You're gonna have if, else if, else if, else if, all throughout. not very convenient for you as a supplier. Okay? Make sense so far? Okay? Now, I just want to ask you don't have to answer me, okay? Do you think this precondition over here is appropriate or not? Only look at that for now, okay? I wouldn't need your answer now because we'll talk about it specifically. Look at this precondition. Think about if this precondition here would be too tolerant or too restrictive. If it is too tolerant, that means it will allow some input value that will cause some trouble later. If it is too restrictive, it would disallow some value that should have been allowed, right? That's kind of the thing you want to think about for your design. Okay, I'll come back to this in just a moment, hopefully today. But okay, that's about version 2. Let's now discuss version 2. I'm going to tell you why it would be an improvement from version 1. Okay, so now from version 1, if you try to say -10 for initialization, that means now you're going to actually, of course, you got to say catch over here, right? By the way, can you see the disadvantage already for coding contracts in, especially preconditions in Java? Let's say you are the supplier, right? You encoded 10 different preconditions or 10 different exceptions for your method. For me, if I try to call your method, how many catch blocks should I write? 10. Of course, I can cheat by saying try and catch exception, but that wouldn't be very useful, right? I want to know exactly which one actually has gone wrong. Okay, you can see already the inconvenience for the clients because in Java, the precondition must be exceptions and the exception must be checked at the runtime, which means whoever is calling your methods, they have to do a long list of try and catch. That's very, very much a burden for the clients. Why should they be bothered by your contracts, right? Okay, keep that in mind. Any questions? Okay. Okay, for this one, nonetheless, for this one, it's going to tell you, okay, we just cannot do it. So rather than doing it, create an object, we're going to tell you, no, we cannot do it. So that will give you the error message. So this is good. Okay, I'm just saying, having this catch block is not very convenient for the clients. Okay, let's do another comparison here. Let's say I try to withdraw minus a million over here, which we know that shouldn't be allowed. In that case, we know that, okay, see, 3 catch blocks for the client. 3 catch blocks, only for a simple example like this for me to write. Why should I be bothered by so many catch blocks? I just want to use call to withdraw, right? And this particular exception will be triggered, and it's going to say illegal negative withdraw argument, right? Okay, that's also appropriate. So this is also good. Okay, I'm just comparing to see go from version 1 to version 2, even though the client is so bothered by the try and catch block, but it's still okay. You know, behavior is still fine. Okay. Okay. So now, one more thing. And if you try to say I only got 100 in the account, I'm trying to withdraw 150. Okay, it's going to trigger just another kind of exception over here because just withdraw amount too large. So it's going to tell you the error over here. Okay. So far we talk about 3 comparisons with version 1. They are the good things, the good stuff. Okay. But now let's talk about the best stuff for version 2 still. Okay, now what I want you to do, look at is this. Do you think it's readable? Kind of. Okay, how about this? I'll go back there. So what I would do is I want you to look at this one here so you can see a little bit better. Okay, so this is exactly what I said. Okay, so now the point is, indeed, adding clear contracts, preconditions, or error condition should not be at the cost of complicating the client's code. The client shouldn't be bothered. Okay, that's a criticism. Okay, now why this is still not a good design? Okay, have a look at this code over here. Now I want you to revisit 13. Okay, line 13. Anything wrong with that, or you think that's okay? Okay, well, go ahead. Yes. You think that should be less than or equal to? Okay, let me just make that change first, and then so now I can go back to the code over here. You're suggesting that over here, so over here, rather than saying balance less than amount, you should be balance less than or equal to amount. That's what you're suggesting. Okay, why should that be the case? Mm-hmm. You cannot withdraw all your balance, right? No, you cannot. Okay, why you cannot? Okay, that's why I put this everything into context. Okay, so guys, let me tell you one thing here. So that's why this one, I tell you what, this one is a bit more complicated than before. So that's why I put everything you should know in one single page. Okay, you know what? Oh, you know what? I forgot. I can zoom in. I forgot. I just forgot. Okay, so now I tell you what, this is the thing you have to change. But let's see why you have to change, right? Okay, why do you have to change it less than equal to? I'll explain the logic in just a moment. But now let's review this particular requirement. Number one, we say that the balance should always be positive, should always be larger than 0. That means the error condition we have over there somehow is a little bit to tolerance. Okay, I'll talk about it. So now let's try the following. Okay, so now let's try this. Okay, let's say we have this client code over here. Okay, let's say we have an account with balance 100, and then we try to withdraw 100. Okay, 100, 100. Now that means the amount over here is 100, and the balance from here is also 100. Okay, so now if I go back over there, let me just wipe out this particular thing over here, okay, to avoid confusion. Now we know that over here, for this, in the original version there, balance is 100, amount is 100. What would be this condition here? What would be the value for this Boolean expression? True? Are you sure? You were teasing me, right? Okay. 100 less than 100 is false. Good. Okay, it's false. For this one over here, it's going to be false. False in the context of Java exception, which means this is not considered as an error. That means we should just go through. That is why when you see from the console over here, it will show that the balance has become 0. And this 0 over here violates requirements number 1. So there's something wrong. Okay? Yes, go ahead.
But right above it, you have code that says your balance can be 0.
Can be 0? Did I say that? You mean where?
A little bit higher when you
Sure.
substantiate in the constructor, for the actual.
For the actual, you mean over here?
No.
The supplier.
The blue box.
Sure. You mean over here?
There, it says if balance is less than 0.
No.
Balance can be 0.
No. Balance less than 0 simply means balance, yes, it can be 0. That's another thing, yes. Oh, good. Okay. So basically, he's pointing out another issue over here, which is similar. Okay. So that means if I simply give you, let's say, I choose a new account, and then I simply put the initial balance, I simply put 0. You're right. And 0 in this case also is going to make the error condition 0 less than 0. False. Good. I'm just double checking. Good. That'll be false. In that case, that means we wouldn't have the error. Okay? That's fine. Okay, you're right. That should be fixed as well. Good. Very good. Okay, but let's focus on this particular one here. Okay? So now, how we change it is another story. I want you to realize the way you define your error conditions, or in the IFO case, the precondition, you have to be very careful. You might be missing some boundary cases. At the end of the course, we're gonna, maybe the last topic, is gonna be something about formal verification of programs. We're gonna show you to say, given a particular goal you want, given a particular implementation, how can you systematically calculate what is the appropriate precondition? That's something we'll do at the end. We don't want to do it at the beginning because everybody might just drop. Okay, that's a bit too complicated for now. Okay, but we do. Actually, that might be nice for us, right? To be less burden. But anyway, we want to keep you. Okay, any question about this critique over here, right? The conclusion is, over here, if you have a error condition like this, it's simply not appropriate because you may have a scenario where you're going to violate this requirements over here, as I explained. If you lose the track, watch the recording. Okay. So now, how can we fix it? Okay. There are 2 ways to fix it. 2 ways. Approach number 1, you can change the precondition, Okay, I'll put it here. Fix number 1, you can simply say balance. If balance is less than or equal to the amount, which means even if they are the same, which means you might have a resulting balance being 0. That's not acceptable. Okay, that's one way to fix it. But now, there's another way to fix it, for which I'm going to introduce a new concept called class invariance. Okay? The reason that it will be more appropriate to use class invariant in this case is because if you try to look at the requirements over here again, when you look at the requirements over here, well, I want you to pay attention to this particular phrase. When we say over here, each accounts, we are in some way doing a universal quantification, which means for every account that is instantiated from the account class, such property must be the case, which means every account dot balance must be larger than 0. Every time you got a universal property that should be true for every instance of a particular class, that should be put as a class invariance. It's more like an integrity property you want to have. For example, I do have some example for you, but we'll see that. Okay. So now let's go back there. So one way to fix, we can either fix the exception condition or we can fix the invariance. Okay. So now that's the what we said. Okay, that one is already covered. Okay. Oh, by the way, I'm not skipping any slides. That's already covered in the iPad. Okay. How should we improve it? So now, without fixing the precondition, so we go for solution number 2. We're going to have something called invariance. Invariant basically saying, whenever you declare an invariance for your class, that means every instance that you instantiate from that particular class must always satisfy that property. Okay, must always. Okay. Now let's do some little bit practice. CS major student, what's the invariance? Let's say as far as GPA is concerned. 4.5, yeah, that's good. GPA larger than, so if I say students 1 dot GPA, it should be larger than equal to 4.5, right? Yeah, every student. Okay, that's invariant. This one a little bit more interesting. What's the invariance for a binary search tree? Which means it should be a global property such that every binary search tree, if you call it a binary search tree, must satisfy. Think about it. It's worth thinking. I'm trying to just gauge you the mindset about invariance. You're more thinking about what should be the single property that every such object should satisfy. What about binary search tree? Why would you call it a binary search tree? Of course, it must be binary, I know. And what else? Anyone? Okay, you want to try? Okay, go ahead. Yeah, but left subtree is like a tree, right? How can you say a tree is less than or equal to something, right? You're getting there. Yeah, you want to say something? Yes. If you say left node is less than or equal to the parents, okay, something like that, I agree, but yes, go ahead. Aha, okay, I like that, okay? So you're saying that if you do a kind of traversal over the tree, the resulting sequence should be somehow sorted. What kind of traversal is that? Pre-order? In order, right? Which means so one way to phrase the invariance would be like this. If you try to do an in order traversal of the entire tree, the resulting sequence should be sorted. Okay, if you got a question about this, speak to me later. Okay, it's nothing to do with this course. Okay, just about binary search tree. Okay, so now how do we code this invariance in Java? Okay, basically this is something you want to say at the end of my method. I want to make sure even after executing this particular method, let's say withdraw, I still can satisfy this property. You can think in this way. Invariant is more like a property that you would like to check at the end of every method. You want to make sure if I call this method here, at the end of its execution, this property is not violated. After calling withdraw, the account balance larger than 0 is not violated, for example. Right? So now let's see how we can do it. For assertion, for those of you who haven't done the assertions, it's very similar to, I'll show you example. Okay? Okay, for example, you can say assert this GPA larger than or equal to 4.5, right? That's one way to do the invariance in Java. And also, you can say in order is actually sorted, right? Just assert. Okay, one thing to note. If you try to do assertions in Java, okay, it's not going to appear, if you generate a Java doc for your class, it's not going to appear on the API, not in the Java doc. So it's completely hidden. That's very bad. Because we say that contract should be the mutual agreement between the client and the supplier. How can the supplier hide the invariance? Right? That's another logical mistake over here. Okay, so you cannot do assertions like that. But you can still do some job over there. Okay, so now what we're going to do for version number 3, how do we fix the amount problem? What we're going to do in version number 3, we're going to introduce so-called invariants in Java. And how do we implement invariants in Java? We're going to do assertions. Okay, so what I will do is I'll show you the code directly. Okay, now this is the code. Okay, the only place that's added, the only new bits you have to look at. Okay, by the way, you can see that the code is getting a little bit complicated already, right? But you can see over here for constructor, this particular part, let me use a different color here. This particular part is really about the precondition, right? If the error condition is the case, I'll throw the exception. And this is the part that we are trying to do the assertion checking for invariance. And now for withdraw, you can see this is precondition number 1 or error condition number 1. This is error condition number 2, and this is the invariant check over here. Okay, and what happened to the implementation, right? It's over here. So this is the implementation, and this is the implementation. You can think about, in the case of IFO, you can done it a little bit more conveniently by using their syntax. But I'm just trying to say for the concept, you can do it in Java, not so easily, okay? Not so conveniently. Are we okay with the invariant so far? You can see that we check the invariance at the end of each method, okay? Maybe in the beginning of next class, I'm going to show you exactly how the contract will be checked at the runtime in IFO, so you can easily debug your program later. Okay, if no questions, then let's now do some critique, okay? So now let's say this. Now let's say we keep the original wrong precondition over there, okay? So now what we will do is we can say, let's say we initialize a account with the balance 100, and we try to withdraw 100. So rather than having some precondition or exception, rather than having that, so this one here is going to be, okay, think about this. The starting balance for that is 100, right? At the end of the method, balance will become 0. That means if I go back to the definition over here, that means when we try to assert this particular invariant over here, this balance in that case would just be 0. 0 larger than 0. False. Good. Thank you. Sorry. That's a terrible joke. I'll stop doing it. Okay. 0 larger than 0 is false. That means you're going to have an invariant violation in this case. Okay. It's not exactly invariant violation. It's just an assertion violation. Just how we coded it in Java. Okay. Try it out. Okay. I do have the source code available to you. Okay. Now let's go back here, and then so that's the two things we have. So now let's say, oh, why better than version 2? Okay, that's exactly what we have seen. So if I try that, you can see that resulting balance over here is 0. So that's why we got this assertion violation. Okay, for invariance. Okay, invariant is not a keyword in Java. We can only code it up manually. Okay, let's go back there, and then let's see something that's more interesting. Why is version 3 still not a good design, right? We want to see why. So now we got preconditions, somehow. We got invariants, also somehow. What other things can go wrong? Okay, let's see. What I want you to look at is this particular code over here, and I have a question for you. Look at this particular code over here. We have withdraw over here. Okay, that's a withdraw we're considering. We got error condition 1, error condition number 2, and also we got invariant condition over here. Okay, everything seems to be working fine. I can tell you as is. Okay, but now remember, so far we only talk about what should be the constraint on the clients. But what about constraint on the supplier? For this particular piece of code, are we constraining the way that the supplier for bank account is going to implement the withdrawal? Are we constraining that? More precisely, If you look at the implementation part for this code over here, this dot balance equals this dot balance minus amount. In this case, you're lucky because the implementer, the supplier, does the good job. They did the right job. However, for you as a client, you don't want to rely on this. You better have the contract explicitly written out as a contract, right? Okay. So now here's a question. When amount is neither negative nor too large, which means these two are not satisfied, okay? Is there any obligation on the supplier of withdrawal? The answer is no. Because basically, between here and here, the supplier basically can do whatever they like. And the program will still run without crashing. Let me show you exactly what I mean, okay? So that means we got to move on to version number 4, okay? Yep. Do we have maybe 10 minutes, I guess, or so? Okay, 10 minutes, okay? So now let's go on for version number 4. This is the most important part, okay? Now for version number 4, what's really the issue over here? I want you to look, okay, again, I will tell you what's the setup over here. So we have error condition number 1 hasn't changed. Error condition number 2 hasn't changed. And also invariant check also hasn't changed. The only thing I changed was I have a very evil supplier. You tell, well, actually, I shouldn't say evil. It's actually the other way. They're like angel, right? You tell them to withdraw, they actually do the deposit. From our point of view, they're pretty good, okay? But, okay, anyway, so it's a wrong implementation, my point, okay? You can see over here, this balance equal is assigned to this balance plus the amount. It's doing something, but it's not exactly what you expect a supplier for withdrawal will do, right? So that's why it's wrong. Can we, first of all, agree this is a wrong implementation? We agree, right? Now, let's see what's going to happen if a client is trying to make use of this version number 4 supplier. Now, let's see what's going to happen here. Let's say we have, again, maybe a little bit counterintuitive. You can see that over here, we have a client with initial balance 100, and then we try to withdraw 50, and then they got 150 at the end. Okay, they might be happy, but again, that's wrong. There's something wrong over here. Wrong about there's no constraint whatsoever on how the supplier should really implement the withdrawal. There's no such contract over here. And so far we talk about precondition, we talk about invariance. Now here's a third thing we're going to talk about, which is called postcondition. Yes. Absolutely, yes. However, you want to be careful. We'll talk much more about postcondition. I would say the most difficult contract to write is the postcondition. We'll see some easy cases here, and then I'll show you the more complicated case. Okay, let's finish this part. Okay, we still got maybe 5 minutes or so. Now, the problem for this is there's no constraint whatsoever to say even if I'm doing this particularly wrong implementation, there's no complaint over here. There should be some complaint. There should be. Okay, good. So now let's see what I meant to say. Okay, now what we want to do is, okay, that's exactly what I just said. Okay, so now what we want to do is okay, that's it. Actually nothing, everything has been said already on the iPad. I'm just going fast on the iPad, so it's more effective. Now, how should we improve it? Answer is we want to add an appropriate postcondition to the method. Okay, in this particular case, it's very easy to write, but let's get a feel. Even for easy postcondition like this, it's already quite inconvenient to code in Java. Okay, let's just talk about postcondition in general. Postcondition specify the precise conditions which it will satisfy upon its completion. Okay, let's see what else to say. Okay, now, can you just read it for me? Okay, just read it first, and then I'll try to rephrase it a little bit for you. Oh, actually, this one is not about the postcondition itself. It's just saying what's the benefits for the supplier, okay? What I meant for you to read is this. Okay, let me give you a little bit sketch. Sorry about that, okay? What I meant to say is this. Thinking this way. In general, if you're trying to say object O dot N, and like a microwave example, for example, right? So now we know that before the method call, the precondition must be satisfied. Okay? After the method call, the post condition in this case must be satisfied. But here's the tricky thing, intuitively. When you talk about preconditions, let's say this. Let me just make it even more precise for you. Okay, let me just erase this one here and tell you exactly what the complication is. If I say account ACC dot withdraw, let's say some amount, doesn't matter what it is, doesn't matter. So now, when we talk about the precondition over here, we just have to say somehow, for example, the amount over here is not too large, also is positive, right? Okay, that's easy. We can even say you can only do withdraw when you got already more than $100 in your account, for example, right? You can even say balance larger than 100. That's okay. But now I tell you what the tricky thing is for post condition. In the case of the post condition, the complication is like as follows. For every attribute in your class, there are two versions of them. One version is the value before the method is called. The other version is the value after the method is called. What do I mean by this? Let's see this over here. Before we try to call this method here, let's say before that, ACC.balance is simply just 100, let's say, okay? And then let's say we try to withdraw 20. After this method call over here, let me use a different color here. After this method call over here, ACC.balance will be hopefully 80, right? So now we got two values for the same attribute to compare, 100 versus 80. Okay, let me give you a more formal name. The case of the 100 over there before the method call is called a pre-state value. It's before the method call. And the 80 over there is after the method is called. It's called a post-state value. And the post condition in general has to somehow draw a relation between the pre and post state values. That is why it is much more difficult to write than preconditions. Okay, but we'll see example. So now, what should we do? Well, now let's say this. For the withdraw method here, how are we supposed to write the post condition for withdraw? Let's say this. If I say before the withdraw, I have some old version of the balance. And after that, I have some new version of the balance. What should be the relationship between them? Yeah, exactly. So that means over here, the balance is equal to, well, it equals mathematical equality. The old version of the balance minus whatever amount it is, right? And coincidentally, that's exactly how you write in iPhone. Old is a keyword in iPhone. And the way they implement the old keyword is very interesting, which we have to spend an entire lecture to talk about. But we'll get there. Not today, don't worry. Not today. Okay, let me see what else, and then I'll let you go. Let me see this. Okay, let's just go finish this slide, and then we're done. So now for the post condition for divide will be whatever result it is going to be, you know what? To do this properly, guys, I have a choice for you. Would you prefer me maybe go, finish the rest of the slides in person next Monday? Or you prefer if I just record some video for you? In person? Okay, in person, right? Okay, maybe we don't have much left for this particular one. So I'll spend about 20 minutes next time, okay? And then I'll see you next time. I do apologize for today, but hopefully it wouldn't happen again, all right?